So we've covered calculating the tangent to a circle, that's a line which touches the circle's edge at a singular point anywhere around it, and looking at getting the equation of this. What I'm going to do here in this video, I'm going to present you a few questions on this topic. I want you to pause the video, have a crack at them, and then come back and check your answer with the working provided here. So here you go. The first one, I'm telling you a line's a tangent to the circle, and I want you to find the point of intersection. The second two, I want you to calculate the tangent to the circle. Difference between the two of them is number 3, I want you to calculate an angle based upon this. And the third one is I want you to find the equation of the tangents from one point to the circle. Now the key thing with that one is the plurality of it. It's tangents, not tangent, tangents. And you'll see what I mean if you were to sketch the diagram. Take that as a hint for part of your working. Right, pause the video and have a crack at these. So the first one, I want to show that 3x plus y equals negative 10 is a tangent to this circle here. Now when you've got a question like this, it's a few easy steps. The first one is make sure this is in the form y equals mx plus c, so y equals something. Then you take this and you substitute it into the equation here. What will happen then is you'll get a quadratic in terms of x. You then want to solve the quadratic, i.e. get it equal to 0 and factorise it. Now if this is a tangent, you'll get one single answer to this. You'll get a repeated root. You can then use that to figure out the y part of the coordinate. So let's take the equation here and rearrange it. So we want y equals, so we have to write it as y equals, shift that over there, negative 3x, take away 10. Now that I've got that, I can substitute it into the equation. So I can say, fine, I've got x squared plus negative 3x minus 10 squared, take away 8x plus 4 times the same equation, negative 3x minus 10 equals 20. Now that I've got that, it's just a case of multiplying out the brackets, simplifying it, and setting it equal to 0. So multiply out these brackets, you get x squared plus 9x squared. You've then got plus 30x plus another 30x, so that's plus 60x. You've then got minus 10 times minus 10, which gives you plus 100. I've got my takeaway 8x, which is there. I've then got plus 4 times negative 3x, well that gives me minus 12x. Then I've got 4 times the negative 10, that gives me minus 40, and I'll shift the 20 over to here, that gives me minus 20, and that whole thing equals 0. So now simplify this and get all the terms together and see what happens. So x squared plus 9x squared, that gives me 10x squared. I've then got 60x, take away 8x, take away 12x, so it's 60x, take away 20x, that then gives me plus 40x. I've then got plus 100, take away 40, take away 20, 100 minus 60, I get plus 40 equals 0. Factorise this now, so take out 10 as a common factor, and I get 10 bracket x squared plus 4x plus 4 equals 0. Then factorise this again, and I get 10 bracket x plus 2 squared equals 0. This then tells me I've got a single solution here. So what I've done here is I've shown it as a tangent because I've got one solution to the quadratic. I've got one point where it can intersect. From this, I can simply say that the x plus 2 equals 0, so x is equal to negative 2. That there is then the x part of the coordinate of intersection. What I now need to do is find the y part. Well, to do that, I can just substitute into here. I then know that y equals negative 3 times the negative 2, that's what the x is, take away 10. Negative 3 times negative 2 is 6, so it's 6 minus 10, which is negative 4. So I can then say find my coordinate of intersection is negative 2, negative 4. Proving it's at a tangent, found where it meets the circle. Second question, find the equation of the tangent to this circle here at the point Q, which is negative 9, 3. Now, to do this, first thing we have to do is find the centre of the circle, then we find the gradient from the centre to here, then we use the fact that perpendicular lines, gradient 1 times gradient 2, m1 times m2 is negative 1, and we get our equation from there. So the centre of the circle C, now remember this is 2f and this is 2g, so the centre of the circle G is equal to negative g, negative f, which in this case is equal to negative 3, 2. So there's my centre of my circle there, negative 3, 2. What I then want to do is the gradient of q to c. Now the gradient of q to c, same formula, y2 minus y1 over x2 minus x1. So 3 take away 2 over negative 9 take away negative 3. 3 minus 2 is 1. Negative 9 take away negative 3. Minus minus a plus, so it's negative 9 plus 3 gives me negative 6. What I then do is I use my gradient properly for perpendicular lines. m1 times m2 equals negative 1. So I then know that negative 1/6 times the second gradient m2 is equal to negative 1. So m2 is equal to 6. So the gradient of my tangent is equal to 6. Now that I've got that and the point where it meets, I can just stick it all together in my straight line equation. I know then that y minus 3 equals m, so 6, bracket x minus a, so it's minus minus, so it then becomes plus 9. Y minus 3 is equal to 6x plus 54. Stick it all across and you get y equals 6x plus 57. There you go. That's the equation of your tangent there, touching the circle at this point. This one here, I want to find the equation of the tangent to the circle at this point. So similar to the last one, what I then want to do is find the angle the tangent makes with the x-axis. So first thing I need to do is the same set of steps before. Centre of the circle, gradient to the edge, m1 times m2 is negative 1, and then get my equation. Well, x squared plus y squared is 100. That has a centre of the origin, 0, 0. So then I can do my gradient. So m from p to the centre equals, and it's the same formula. Well, negative 8 take away 0 over 6 minus 0. That ends up giving me negative 8 over 6, which is negative 4/3. Use the perpendicular property, m1 times m2 equals negative 1. I then know that negative 4/3 times m2 is equal to negative 1. So my gradient of my tangent, m2, is equal to 3/4. Then it's just firing it all together, using p, the point where it intersects. I've then got y minus b, so y minus minus 8 gives me plus 8, equals 3/4, my gradient of my tangent, bracket x minus 6. It's then multiplying all this out and getting it in a simple form. Now, if we left it as y equals mx plus c, I'd end up with fractions everywhere. Let's put it in the general equation of a straight line. Multiply everything by 4 to get rid of the fraction, then multiply out. You get 4y plus 4/8, 32, equals, multiply out the bracket by 3, 3x, take away 18. Stick it all over here, and that's you got it sorted. So I've got 4y, take away 3x, I've then got 32 plus 18 plus 50 equals 0. So that's me got it in the general equation of a straight line form. Job done. Second part though is I want to know the angle it makes with the x-axis. Well, remember, the angle it makes can be calculated from the fact that gradient m equals tan theta, where theta, if you remember right, if we've got a straight line, is this angle here. So theta is given by that angle there. Now in this case I've got the gradient equals 3/4, so I then know that tan theta is equal to 3/4. From that I can then simply say that theta equals tan minus 1 of 3/4. Stick it in your calculator. What you end up getting is that tan theta equals 36.869, and it continues on. So it's then 36.9 degrees. So the angle it makes with the x-axis, this bit here, is 36.9 degrees. Calculated that bit there. This is a hark back to National 5 stuff. We did m equals tan theta back then. Remember that from there. Last one was find the equation of the tangents from the point A at 0, negative 4 to the circle x squared plus y squared equals 8. Now, as I've said, you'll notice the plurality. It's tangents, it's not just tangent. So if you think about it, if I was to sketch this here, set my axes up and I draw my circle, what it means, if I extend this down to here, 0, negative 4 is down at negative 4 on the y-axis. What it means is I've got two tangents, one touching on this side and one touching on that side, and I want both of those tangents. I want to get the equation of both of those tangents. It's how you go about it. Well, we know the general equation is y equals mx plus c. From this, we actually know that c, the y-intercept, is negative 4. So I know then that y equals mx minus 4. I know it's this form. All I need to do is calculate the gradient. But it's not just as simple as looking at this and going, ah, there we go, it's that one there. I could use the way it cuts the x-axis, but I don't know any information to calculate that. However, what I can do is take this, substitute it into here, and solve it. So let's try that. So I've then got x squared plus, put this in here for that, I get mx minus 4 all squared equals 8. Multiply out the bracket, I get x squared plus m squared x squared, take away 8mx plus 16 minus 8 equals 0. So what I end up then getting is 1 plus m squared times my x squared, take away 8mx, 16 take away 8, plus 8, and that equals 0. What I can now then do is use my quadratic formula, but more specifically the discriminant. I want to use the b squared minus 4ac. Now we know that with it being a tangent, it's going to touch at one point. So in order for that to do it, we need a repeated root. So we know b squared minus 4ac has to equal 0. So take the information here, substitute it in here, and what we should hopefully find is a quadratic for m, which gives us the two values we want. So if we put it all in there, we get negative 8m squared, take away 4 times a, which is the 1, plus m squared times the 8, and that equals 0. Multiply all of these out, so the 8m squared, that gives me 64m squared. Take away, well, 4 8s are 32, and then multiply at the bracket, I get 32, take away 32m squared, and that equals 0. Simplify this all, I get 32m squared minus 32 equals 0, and now we factorise. Common factor of 32 comes out, I get m squared minus 1 equals 0. So if I then look at this, this is actually a difference of two squares. This is a squared minus b squared, so I get 32 m minus 1, m plus 1 equals 0. So from this, I get my two gradients. From that, I can say the gradient equals 1 or negative 1. So I can use both of these to get my two equations. I'll get one equation here and one equation here. What I can then say is therefore y equals x minus 4 or y equals negative x minus 4. The one here is the negative x minus 4, it's coming down the way. This one here going up the way is x minus 4. So this one's slightly longer and more complex, but it's using the properties we know of tangents and of quadratics. We know that a tangent touches once, solving a quadratic always has a repeated root. This here's the key bit of information there for that. These sorts of questions can be quite complex, but it's all about thinking about the properties of circles, lines that intersect with them, and the properties of straight lines we've covered back in National 5 and the early stages of higher. We have to be able to recall this knowledge and work it in, and that's where all of this comes through for these types of questions.